history of providing value to our customers. 100 years worth of history. That's something that we wanted to make sure that we continued moving forward.
The first truly aerodynamic truck on the road was the Kenworth T600.
Kenworth T600.
And what we really wanted to look at was what the next 100 years might be like.
Vehicle teams really started with a blank sheet of paper and thought about, okay, how does the next generation looks like?
Normally when we start a program, there is already something there. There's already a truck that we know.
We started from scratch.
This is the kind of a concept design that often is just a sketch.
We really had to go all out on this and really crank everything up to 11.
We learn what works, we learn what doesn't work.
You'll have to be a little bit creative.
You're really free to do whatever you want to increase performance, but it really does become a challenge because now you're not constrained.
We really wanted to push this beyond just a demonstrator. We wanted to show something dynamic and what the future of Kenworth might look like.
The goal of the project was to get 100% freight efficiency improvement over our baseline vehicle.
Our baseline was a T660, which when it was launched was the most aerodynamic vehicle on the road.
Now that vehicle, as everyone knows, is extremely efficient, which put ourselves at a little bit of a disadvantage because we had such a great baseline to overcome. We had to be 100% better than that.
Just to create a basic aerodynamic shape is not the hard part, but there are lots of challenges to actually practically achieving an aerodynamic shape. And we have to work with the engineering teams to be able to make that a reality.
Your cooling module can't be out in front of the vehicle. You also have the frame rails themselves, you have the front axle, you have the engine, its relationship with the front axle, the transmission, the drive shaft, the fuel tank.
The biggest surprise to us was when the engineering team told us they could actually figure out a way to enclose the front wheels on the vehicle.
We came up with a chassis that is very different than traditional trucks. We have a reverse splay chassis. We can actually put most of the powertrain content between the rails. The engine is actually placed behind the front axle and lowered. It enabled us to narrow the front so that we could get the wheels within the bodywork.
And that's something that we've never been able to do before. And really, it looks like it was shaped by the wind.
We were able to make the windshield very parabolic and smooth to the flow as it possibly could be. We were able to go one step further and really eliminate the mirror altogether, and now we're just using cameras, so it minimizes what is coming off the tractor surface.
The center driver seemed to lend itself best to a more narrow front end. We were able to separate the driver area from the sleeping compartment.
There's a staircase on the side that makes it easy to walk in and out like you're getting on a coach or something.
We have the entire hood and the chassis fairings mounted directly to the cab, and they then move with the entire cab.
Knowing that trailer is typically half of the drag that contributes to the overall energy loss, it's something that we had a real opportunity where we could design everything as a system together, and we knew how the air would flow from the very front of the bumper to where the trailer ends.
This is really meant to be a test bed for future technologies. We have very stringent standards with regards to performance expectations. Once the vehicle was built and transferred to the technical center, we put the truck through its paces, just like we do all of our trucks. And this is a truck that incorporated advanced technologies that are cutting edge, and so for it to perform as well as it did was a great success.
This vehicle performs exceedingly well.
We've been able to increase the performance of this vehicle by nearly 50% from just a drag perspective.
The truck is around 14,000 pounds. That allows you to put a lot more goods in the trailer.
The engine was very special because we were able to achieve the goal of 55% engine efficiency. It's what we call a diesel-electric hybrid powertrain.
It's a production MX-11 with a production transmission, and the axle itself is also based on our PACCAR axle. The engine is so efficient as is that we don't have to go out of our way to make it more efficient in order to hit this target.
Today's modern engines will do at most 47%. So reaching 55% is a major step in efficiency.
We've been able to increase the vehicle's range significantly, which allowed us to reduce the volume of the fuel tank down to 80 gallons, which is all the typical driver will need on a regular day. So we've got a very high MPG number that we're very proud of.
If this engine would go in production, it would mean a 10% improvement in fuel efficiency by the engine alone, which is an astonishing number.
We wanted to make a vehicle that was future-proof in order to accommodate things like hydrogen tanks for our fuel cell and internal combustion engine vehicles, or batteries for the BEV vehicles, or any sort of other technology that we might need to accommodate the future project.
So I think what this program has allowed us to do is really understand what is possible.
We didn't only break all the records in engine efficiency, but we also will see those technology being adopted in the market in the future.
So to see something that is a sketch come to life and be running down the road and proving some of these things out is really exciting.
The fact that we have paid tribute to that legacy is something that's somewhat sentimental to me.
This is an important milestone for us to kind of look forward and see where we might be going in the future.